This is the solution video for question 35 from part B of the 2019 ECAA paper. In this question, we're told a bag contains only red balls and green balls. The probability of picking a red ball is P, and the probability of picking a green ball is Q. And we're told Q is greater than or equal to P. We're told then a ball is picked from the bag, its colours noted down, and then placed back in the bag, and then we do that again once more. Now, the probability the balls are the same colour, take away the probability the balls are different colours, is a quarter, we're told. And from all this information, we're asked to find the value of Q over P minus P over Q, and we're given 5 numerical options for this value. The key to this question is to construct some equations with P and Q. Preferably a pair of equations, and we can figure out what P and Q are, and then we can figure out the value of this. So, what can we say about P and Q? Well, firstly, we know P plus Q is equal to 1, as P and Q are probabilities. And if P and Q encompass the entire set of things that could happen. So what else do we know? We're told that probability balls are the same colour minus probability balls are different colours is equal to a quarter. So what's the probability balls are the same colour? Well, it's this, because we could pick a red ball and then a red ball, so P times P, so P squared. Or we could pick a green ball and then a green ball, Q times Q. And obviously both these events can't happen at the same time, so we can just simply add the probabilities. So that's the probability balls are the same colour. And then what about probability balls are different colours? Well, we can pick a red then a green, or a green then a red, so PQ or plus QP. And again, clearly these can't happen at the same time, so we can just add them. And we know if we do this, we get a quarter. So let's expand this. So P squared plus Q squared minus 2PQ is equal to a quarter. And you'll notice that this looks like the expansion of something. Indeed it is. If we do P minus Q squared, we get P squared plus Q squared here, and this minus this 2PQ term here. So what do we do from here? Well, we want to square root both sides to get P minus Q is equal to a half. But we've got to be a bit careful, because we know Q is greater than or equal to P. So we know if we take the positive square root of this, we don't get P minus Q, we actually get Q minus P. So our next line is Q minus P, not P minus Q, is equal to a half. Well, this is great, because we have two equations containing P and Q. So we can solve these simultaneously for P and Q, and we can get to our result. So let's do that. So let's label this equation 1, P plus Q, and Q minus P is equal to half. And let's do 1 minus 2, because we know that will cancel the Q's, and we'll get as an expression in P. So we get P minus P, so 2P equal to 1 minus half, which is a half, which clearly implies P is equal to a quarter. And if we look at 2 and P is equal to a quarter, it's clear to see that Q must be 3/4. So Q is 3/4. So P's a quarter, Q's are 3/4, and we're asked to figure out this. So let's just put the numbers in. 3 over 4 over 1 over 4, minus 1 over 4 over 3 over 4, times everything numerator and denominator by 4, and we get 3 minus a third. And then 3 minus a third is 8 over 3, and this matches with option D in our multiple choice, and so our answer is